All right. Any questions? So let's open up to you. We've got the same format for this exam as the previous three. So because of that, on average, students do well because you've got a good idea at this point as far as how the exams are structured, where I'm going to get questions from, and all of that. Well, let's turn it over to you. Which one are we going to answer first? Discuss first.
Can we go over the one about Benton County?
Describe the key reasons why Benton County has the best soils and Crawford County has the worst soils. So this all relates to the soil formation controls. So that's also pedogenesis, I believe is what the professional geologists and geographers would say. So soil formation controls. What are the 5 soil formation controls? I know this isn't explicitly asked for this question, but it definitely helps in answering it. So what are the 5? Who wants to help us out? Rattle them off. Soil formation controls. And so when we think about soil, obviously the theme of that video lecture is just more than just dirt. It varies from place to place, and it has a much more useful purpose rather than just housing dead people in caskets and all that stuff. Sorry to get it sort of negative. But it also gives us food. We love food. Soil formation controls. Start rattling them off. Parent material. So the first one would be parent material. Parent material, that's just essentially where the soil, the underlying soil, come from. So parent material. So when we look at parent material, we can think of it in 2 different ways. We've got residual soil and then transported soil. So in terms of parent material, we've got 2 types. Residual soil, that's essentially stuff that's been there for a long, long time. It's essentially the residual soil is the underlying bedrock. So one of the things you would have learned in the soil discussion is the fact that that bottom layer, the regolith layer, and that underlying C layer, that rock, the R layer, the rock, essentially over time breaks down because of erosion, because of weathering. So the soil that's left behind from those processes are referred to as residual soil. And these typically are old. Transported soil is stuff, as the name implies, it's not residual, it's not just been there for a long, 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 long time. Instead, transported soil has been brought and distributed via different means. It could be flowing water, rivers, could be moving air, could be glaciers. Overwhelmingly, it's glaciers. And so transported soil is going to be younger soil. So it's fresher, it's been laid down, it's newer. Hopefully that makes sense between young and old, but also in terms of residual and transported soil. So amongst those 2 options, old soil versus young soil, or in other words, transported versus residual, which one's better? Transported soil. So transported soil is better. So in other words, young soil is better. Not good for the child molesters. Bad joke, bad joke. So young soils are better than old soils. So that's the first thing. I'll come back to Benton County and Crawford County here in a minute. A second key control. And I guess we could also, another key control. Climate. And so climate would be another key control. So of course throughout the semester we've learned there's areas that are quite dry, areas that are quite hot, areas that are quite wet, areas that are kind of in between. So we learned all about these different climate types. So when we think about soil, good soil typically is found in areas where we have the temperate climates. So temperate, we can also associate with mid-latitude cyclonic systems in those areas, in the mid-latitudes. So temperate just means seasons. So soil likes having seasons. Further, it doesn't like too dry. It doesn't like it to be too wet. It likes it to be somewhere in the middle, which we also find there in temperate areas. So other things to note is areas that get a whole lot of rain. So tropical areas, they get a whole lot of rain. Is that good or bad for soil? A whole lot of rain. Bad. Why is it bad? Leaching. So essentially the good stuff. The stuff that helps stuff grow, the stuff that plants like. In tropical areas, it rains so damn much that essentially all the good stuff's washed away. So that's not good for soil formation. That's not good for vegetation when you have areas that get a ton of rain. So rain, bad for soil. I should say heavy rain. Because we don't want the opposite of that. Dry soils is the absolute, absolute opposite of that. So essentially climate, just like us, we like things to be kind of there in the happy medium. We don't like to be super, super hot and sweating all the time. We don't like to be cold and dry. We like somewhere in the middle, and it's the same with soil. So the second soil formation control is related to climate. Third one, slope. So slope. And we could also kind of slope and orientation kind of go hand in hand. But the moral of the story there is flat, good, steep slopes, bad. And so flat surfaces, that makes sense. So we think about soil. I mean, it needs water. For soil to form, it needs to be on a flat slope so that that water just doesn't remove and wash away all that material, all of that, that soil, all that top layer. So when we look at places that are flat, it does a much better job of draining water. So flat areas, better soils than hilly areas. And that just makes sense. I mean, think about a steep slope, that water is going to run off instead of working its way through the soil, forming the soil, pedogenous and all that good stuff. So we look at slope and orientation. Flat soils are better than rugged topography, steep slopes. All right, let's give me a number 4. Time. So time, we can also kind of just throw in time with the parent material. So we could do it in 4 or 5. So we'll just go ahead and say time. But it's a good thing that we're kind of on the same page here. Parent material and time, they kind of go hand in hand. But the moral of the story is old, bad, young, good. So we can relate that also to good. So young is good. So we can also relate that to transported residual soils or the parent material. Number 5. Flora and fauna. Flora and fauna, plants and animals. This is a fancy way to say plants and animals. And so that's where you can come back and use the description as far as forest land versus grassland. So when we think about plants and animals, we've got forested areas in terms of types of plants, types of vegetation, but then also grasslands. Now, which one of those is better for soil formation, for growing stuff? Grasslands. So grasslands, not saying forest lands aren't bad, obviously. Dense forests, wherever those trees come from, they wouldn't be able to grow if it wasn't for the soil that was there to provide for. But grasslands are better. So all that's described in that video lecture as far as the roots, and how they bring nutrients to a deeper, they penetrate deeper into that soil layer as they get down to the O, they have a much bigger A layer. All of that I described when we have that image of a forest land and a grassland side by side there. So it's from that one video lecture, but that's also popped up a few different times. So forest land versus grassland. But that's the plants. We also think of animals. So think of areas that have earthworms, fungi, bacteria, do a good job of breaking stuff down. So you can also think about animals. Also have I just lost my train of thought. Humans. Humans, we're animals. So I didn't really talk about humans, but we definitely can play a key role in altering the natural formation of soil. So you can throw in humans as well. Kind of relating it to the more recent topics we've had in the class. So that didn't answer your question. But now let's use this to answer that question regarding Benton County and Crawford County. So essentially these two counties are complete opposites. One is absolutely great for soil. Benton County is up in the northern part of the state. This is in video lecture 9.7 at the very, very end. This is probably why most people don't get a chance to watch that. It's at the very, very end of video lecture 9.7. I specifically describe these two differences, these two counties. Benton County up in the northern part of the state, Crawford County down in the southern part of the state. So we have two different areas. One county has the best soils in the state, the other county has the worst soils in the state. So Benton County, things that Benton County has going for it. First off, it's grassland. Benton County is a grassland. Crawford County, forested area. So we think about those two options. Which one's better? Grasslands. So we can, the tail of the tape. So we'll go ahead and give the first one to Benton County because it's a grassland in terms of its vegetation type, where the other one is forest land. Another thing we can say is the type of soil found there. Benton County has been influenced by glaciers. So those glaciers have brought sediment with it. And so what we have is we have transported soil. So we have transported soil, which is also younger. Whereas in Crawford County, it's got limestone. It's got essentially this bedrock that's just essentially real close to the surface. And so it has hardly any soil because of the fact that it's that residual soil. It doesn't have transported soil. It's been added to the soil there in Crawford County. So residual or older soil. And so once again, young versus old. As we learn which one's better, younger. And so tail of the tape, another check for Benton County compared to Crawford County. Now let's look at climate. In terms of climate, so we have Benton County, one of the driest counties in Indiana, whereas Crawford County, next to the counties up there by the lake, it gets a whole lot of lake effect snowfall. Crawford County gets, on average, the most amount of rain. So high precipitation. So it rains quite a bit. And between those two, when you have lots of precipitation, lots of rainfall, that means more leaching. Once again, leaching is the removal of the good stuff. Leaching is the removal of the nutrients, the organic material, the stuff that helps stuff grow in the soil. So because it rains so much, it washes away more of that particular good soil. So tail of the tape, another one for Benton County. Other things to say in terms of slope. So we think about Benton County, it's extremely flat. Anybody from there, Benton County? Benton County is up there just a little bit north and west of Lafayette. So just imagine going north towards Chicago, super duper flat, from one horizon to the other. And that's very much what you'd find in Benton County. Benton County is, of all the counties in Indiana, one that looks the most like Kansas. It's a big old prairie, essentially. Whereas down in Crawford County, this is an extremely rugged area. Sinkholes, karst valleys, all kinds of river valleys. And the White River, East Fork has cut through this particular area. So it's quite rugged. And so once again, steep slopes, rugged terrain. That's not good for soil formation because water goes down the slope, runs off, and essentially removes, once again, the good stuff. The O layer, the humus, and the A, and the organic rich material. Oh, did we get them all? So tail of the tape, flat, much better than rugged. All right, did we get them all? I think we did. So that essentially takes that first question that you didn't ask, but I essentially fleshed out those key controls, and then we apply those to answering the Benton County and Crawford County question. And once again, this is all found at the end of video lecture 9.7. And if you watch it, there's a little reward at the end, as you'll see. Those who've probably watched it. So that should entice you. Watch that video. Watch the end. A little nougat. That answer? Cool. All right. Next question. So that takes care of the questions. Describe several key soil formation controls. That's 1 through 4-5 that I did. And then the other one, describe the key reasons why Benton County has the best soils and Crawford County has the worst. So essentially, what that question does, it's highlighted right now, is it applies the first question. And boy, I love questions that apply things. Any other questions? Yeah?
So at the bottom, when we have to fill in the boxes, besides filling in the names, what do you want?
So we're on a different question?
Yeah.
Okay. What question are we on?
The last one. The human.
Very last one.
Yeah.
Describe fracking in the Great Plains?
No, I'm the one with the box.
Oh, this one right here, the box. So what was your question?
Besides filling in the names, what do you want?
So then from there, so being able to fill in each of the 5 boxes, that's cool. That's like one point right there. But then from there, focus in on the first 3 boxes. So what do I mean? What do you mean by human driving forces? When we look at the second box, what do you mean by human activities? What are some examples of human activities? The third one, environmental change. What are some specific examples of environmental change? And then look at, okay, some consequences of each. So I highly suggest taking just anything that we've talked about. For example, kudzu. No, let's go to Three Gorges Dam. So I really had a chance to talk about in lecture the Three Gorges Dam. Three Gorges Dam, why are they doing that? Because of the indirect, the driving forces that people want electricity. Huge population there in China, so a lot of people need electricity, so the Three Gorges Dam provides that. So what's going on is increasing demand for electricity in an area with a huge population. You can see then what leads to the human activity, constructing a dam, building a dam. That's now where we're going to see changes to the environment. This is the fact that Chinese women are having children, just the fact that Chinese are wanting electricity, that doesn't cause environmental change. But no doubt the construction of that dam to satisfy those driving forces does lead to environmental change. So human activities would be the construction of the dam, the harnessing of the flowing water. So then we have environmental change. And so with the dams, environmental change is you're altering the natural state of things. Rivers have their natural ways in which they move over time. Now what you're doing is putting up a big old wall that's blocking this natural flow of this river that's been flowing around for obviously a long time. So one of the things is the consequences from the Three Gorges Dam. There's several consequences, but one of them is you had to move a bunch of people because essentially 13 cities about the size of Fort Wayne were flooded. That's kind of a consequence. That's kind of something you got to figure out and deal with. Further, all that trash and debris that starts to pile up behind the dam. Another problem they have. Another consequence. Other consequences they have are, that, for example, that Chinese sturgeon. That thing's been around for 140 million years. And just after the construction of the Three Gorges Dam, it was almost endangered. It was almost gone. It's right now, I think, on the endangered list. I haven't checked up on it in a while. It's something that's been around for 140 million years. Boom. Almost extinct, almost gone from the construction of this dam. Consequences. So it's a way that we can also, when you think about this systems approach, apply maybe kudzu to it. Apply fracking to it. So we can apply fracking in terms of increasing demand for domestic energy sources. The fracking is the human activity. Then we have the environmental change, the polluted water, the toxins, the unknown as far as what's going to happen in 20 years to these particular areas. So the systems approach, when you answer that question, focusing on those first 3. But then, when you do that, showcase and include an example to showcase and apply that, yeah, I understand the systems approach and I can apply it to some environmental issue. Cool? All right, so we answered a few different questions, but let's keep them coming. Yeah.
Can you go over the formula?
I equals P times A times T. So describing the I equals P times A times T. So being able to tell me what the letters mean. I guess also, let me just step back. First explaining, okay, what the purpose of this is. And what it is a way to look at and understand environmental impact. So what we can do, why this formula is so useful, is we can learn about environmental impact, but we can start blaming and saying to certain areas of the world, to certain groups of the world, hey, take care of this. This is something that, it's definitely a key problem in your country, and it's really the key issue as far as affecting the environmental impact in your country. Whereas in another country, it's a whole other issue, a whole other list of concerns. So being able then to say, okay, tell me what each of the letters mean. I stands for impact. P stands for population. It's kind of the obvious, more people, measured in just pure numbers. Affluence is just essentially more wealth. We have more money, you can buy more stuff, so then you're going to be utilizing more resources. So there's, you look at high-income countries, like the United States, we use a whole lot of fossil fuels. We emit a whole lot of air pollution. So for us, our affluence is because we use so many resources just to manufacture our goods, just to actually, to do our jobs, or just to move us around. We all use a lot of resources. Much different when, for example, we went to Guatemala. When we went to Guatemala there, the average, dollars spent per week on food, much lower because everything's more local. So all that has to do with affluence. Technology is a little bit more complicated. Essentially, technology means as your technology increases, that's now more computers. You have the life cycle of a computer. Every 2 years, you got to get a new one. Where in lower income countries, the whole community almost shares one computer. So for technology, the more resources, but also the higher technology, you need even more resources for those various technologies. And so the iPhone, every single time a new one comes out, my gosh, we got to stand in line at midnight to get a new one. Another way to showcase technology, I mentioned this beforehand, is a computer chip. To make one computer chip, massive amounts of resources needed just to make that computer chip. Also, you think about your iPhone. All those various components of your iPhone, your smartphone, they come from all over the world. They come from all over the world. They're essentially assembled, then eventually, obviously consumed by you here in the US of A. So higher technology, more resources needed, more resources required. So they kind of go, A and T go hand in hand. So if you're asked this question, something to also do is to kind of once again, like I say, why I like this formula is we can lay blame to certain areas of the world. So our lower income countries of the world, developing countries is what they're also known as. Poorer countries of the world, affluence obviously isn't their problem. High technology, that ain't their problem either. The problem is overwhelmingly huge population. So you look at where's population in the world growing the fastest. It's growing the fastest in developing countries, particularly in their urban areas, particularly in their cities, is where population is growing the fastest. And so I know some people will snicker, but for those lower income countries, control your P. Your P is way too high. Lower that, and that would be one useful way to lower our overall environmental impact. Of course, that's hard to do. It's hard to say, hey, stop having babies, stop doing everything you're doing, stop your culture. All of that is harder to do, but no doubt is a key concern in those lower income countries. In our high developed, our wealthier countries, it's being mindful of that affluence, being a little bit smarter about how we use resources. And that's the whole idea of this ecological footprint, is coming up with ways to lessen your environmental impact, because we all use a ton of resources here in the US of A. So affluence, and so some things I've already seen mentioned. Carpooling is a way to reduce your impact on the environment. As instead of being selfish and driving yourself, coming to school or going to work with coworkers to reduce the resource usage. Other things I heard, eating more local foods. I've seen that in the ecological footprints already. So instead of eating a bunch of processed food, instead of eating rallies every night, it's not good for you anyway because it's going to clog your arteries. But it's also a lot of resources. That stuff, that cheeseburger, it ain't local. It's not from down the street. It's not down from the grass-fed farm. It's probably who knows where it's from. It's probably from the wrong end of a cow, but probably somewhere in the Great Plains. So it comes from a long, long way. I don't know if that answered that. Yeah, cool. So when you answer that question, if that question is asked, be able to explain a little bit more than just P stands for population, A stands for affluence. What do I mean by that? What do you mean? How's population matter? So the simple way is more people, more scars in the land, more resources, more people, more resources, yada, yada, yada. That's that segue into the next question. Describe several key shortcomings or problems with the formula. And so why I also like the IPAT formula is it's got problems, it's got flaws, but we can use those flaws to further understand human impact on the environment. And this first flaw that we identified in this IPAT formula is the fact that affluence and kind of technology can come up with ways to lessen our impact on the environment. So because we have affluence, for example, in the United States, we can set huge amounts of area, set it aside for parks, for national parks, Yellowstone, Jellystone, Eagle Creek, locally, which is the nation's largest municipal park, right here in Marion County, the nation's largest municipal park. And so that's definitely a first world problem, being able to set aside land. In Nigeria, and throughout much of Africa, throughout Latin America, the whole idea of setting aside huge amounts of land is much harder to do. Those are countries in which they need that land. It's needed for resources, needed for ways to generate income, needed for generate food for the local population. So one of the shortcomings of this formula is affluence can actually lower your environmental impact. Same with technology. So other examples of technology, what are some other examples of affluence and technology lowering our economic impact? Yeah.
People go out and study animals and plants and everything and do experiments and try to improve everything. So
the fact we have science and research and development, science, technology, biology. Those are, once again, you're going to find those in Europe, North America, parts of Asia. That's where the researchers are going to be located. And so they're going to be coming up with better solutions. They're going to be more aware of pollution, having sensors to monitor pollution in a particular area. For example, water quality. Water quality is something, I know that White River is the last place you'd ever want to step your foot in. But it's actually, they measure the quality of that water. It's always being monitored. Even if there's dead bodies in there, they're still monitoring it. And trust me, much cleaner than other places in the world. Go to Africa, go to sub-Saharan Africa, and you'll see some of the waterways are absolutely polluted with feces, plastics, trash, this, that, and the other. There's a picture I saw over the weekend of the Mekong River, which is in Vietnam. It goes through this town. I don't know if we can find it. I'm probably sure someone could Wikipedia it. But this river was going right through a town. You couldn't even see the water. All it was just covered in plastics. So we can see, in poorer countries, definitely that's more common than here in the United States, where we have all this water quality, and we have all these. In fact, there's an internship available for geography majors studying the water quality of Indiana's rivers. Anyway, so other shortcomings or problems with the formula. The big one, is the fact it doesn't really account for individuals. So what I liked about the formula is we can label it certain groups: low-income countries, take care of your pee; wealthier countries. You got to be mindful of that affluence, or take advantage and use that affluence to lessen your environmental impact. As far as individuals, they no doubt have a key role as well. So individuals, the example I used beforehand was Saddam Hussein, who got all pissed off at some tribes in the Iraq. So what he did was he essentially just dried everything up. Just kind of rerouted these rivers, and essentially this area where these people that he was all pissed off lived, they essentially just dried up all their land. So that's environmental change from one person who was all pissed off. And so once again, the military, as I've told that story last time I believe, the military came in, knocked down some of those dams and brought the river back to its old state and brought back the lushness of the marsh and the swamplands of this particular area. So rejuvenated and brought the area back to its previous condition before that environmental change. So individuals play a key role. There's also an example I used last time of the coal mine. So I can become they'd probably erect a statue of me in some poor West Virginia town when I'm the one that tracks the coal mine company to come in. So for the short-term benefits, we've got economic jobs, all this prosperity, everyone's happy, everyone loves me. But 15, 20 years from now, the coal company, they will pick up and leave. So when they pick up and leave, they leave behind their remnants, the strip mine. They leave behind their mountaintop removal. All that crap that's been removed, it just lays there. Further 20 years from now, my healthcare costs are through the roof because I have all my locals have black lung disease. They have lung cancer from inhaling all that soot and coal dust. So that's kind of a way to showcase the role of individuals. So it's great. I attracted this coal mine, but you can see how the environmental, but also the consequences, the human consequences of that down the road. So it's often the kind of thing you have to do is weigh the short term versus the long term with a lot of these. And that's the role of individuals. Another shortcoming, I really didn't talk about too much, but I did definitely mention, and that's the role of culture. So the role of where we come from. So I don't see a C in anywhere in that I equals B times A times T. And C, if you grow up in a family that uses all natural stuff, doesn't is off the grid, whatever. Maybe you know someone who's like that, the super earthy types. They're of course going to be growing up in a family where they're very environmentally conscious. But I grew up in the suburbs. Before I even took a geography class, I just burned the hell out of the gas. Let's drive all over the city. Let's drive wherever we want. It's in suburban areas. Let's use those resources. Everybody needs to have their own bedroom, their own bathroom in the suburban area. And by gosh, I get scared at night, so I'm going to leave my TV on at night. So those are all examples of culture. It's how you're raised. So if mom and dad don't tell you to turn that TV off at night, then it's just a way of life. It's how you live. So culture is another key part of the IPAT formula that's not mentioned. Yeah. Oh, sorry. Yep. Oh. Next question. Any other questions?